Hello and welcome back. Today we are doing discrete math again, and we are continuing part 2 of Introduction to Logic. Okay, so we're going to look at some notation for inequalities using and or. So first we have x less or equal to a. So in this one we could say x is less than a, or x is equals to a. All right. The next one we have a less or equal to x less or equals to b. This one means a less than or equal to x and x less than equals to b. And by this one, using the above, we could say a is less than x, or a is equal to x, and x is less than b, or x is equal to b. All right, let's look at some example over here. Suppose x is a particular real number. Let p, q, and r symbolize 0 less than x less than 3, and x is equal to 3, respectively. Write the following inequalities symbolically. Okay, so first one we have x less or equals than 3. So I'm gonna write that yellow. So look at our first screw up.
It was at this moment he knew. He fucked up.
Line over here, we have x less or equal to a, which means this one is x less than 3, or x equals 3. Okay, first one is easy, right? Actually, yeah. And then now we're gonna do it symbolically using p, q, and r. So what is our letter here? X less than 3 is q, right? So q, and then or, I'm gonna use yellow, or x equals 3, so is our r, right? Q or r, that is our statement. All right, the second one we have two statement over here, which is, let's do another yellow. Okay, we have 0 less than x and x less than 3. Okay, so let's do it symbolically. We have 0 less than x is our p, right? So I'm gonna write p here, and then I'm gonna use red for and x less than 3, which is our q. So p and q. All right. Okay, the third one we have 0 less than x less or equal to 3. So let's write something simple. Let's break it down. First we have 0 less than x and x less than 3, or x equals 3. This one is a term in parentheses, right? Okay, let's do it symbolically. Go ahead and pause and do it by yourself. Okay, so we have 0 less than x is our p. I'm gonna write p here and symbol. And then we have the parenthesis. x less than 3 is our q, right? Q, and then or x equals 3 is our r in parentheses. So this one is our symbolical inequalities. This is one of my favorite one in this topic. It's called logical equivalence. And so the definition of logical equivalence is if you have two statement forms, all logically equivalent if and only if they have identical truth values for each possible substitution of statements for the statement variables. So we can denote the logical equivalence of P and Q as P, and then you see three, how you say it, like 3 lines equal sign, and then Q. Okay? So look at our example over here. We have P or parenthesis P and Q. And is it logically equivalent to P? So first, to test it out, we need to construct a truth table with the truth values of P and Q, right? Okay, I'm gonna draw truth table. No, looks really nice, but okay. Okay, so we have P, Q, P and Q, P or P and Q, and then P. Okay, so P and Q, which is our variables, and then this line here, P and Q, is the parenthesis. This whole thing over here is just like the first term, the left side of our statement, and this P over here is just our P, the right side of our statement. Okay, so how many rows should we have in here? Is in the last video, you guys can check it out. So we have 2 variables, so we need 2 to the power of 2. 2 squared is 4, right? So we need 4 rows. So we have true, true, false, false, and then true, true, false, true, false. Okay, so we have P and Q. You know that P and Q is only true if both variables are true, right? So the first one, true, true, is true. True, false is false. True, false, also false. And last one is also false. Okay. So we have P or parenthesis P and Q. So now we look at this line and this line, right? Okay, so we have true or true is true. And then true or false is also true. False and false is false. False and false is also false. Okay, so rewrite our P again. Okay, so we know that you have true, true, false, false for both columns. So we can jump to the conclusion that since the last row or no, let's say P4, P5, the columns P4 and P5 have the same truth values. Therefore, P or P and Q parenthesis is logically equivalent to P. Okay, to prove something logically equivalent to something, you just need to show they both have the same truth values as each other. So yeah. Okay, let's do another example, shall we? Okay, next example we have parenthesis P and Q or R is that logically equivalent to P and parenthesis P or R. I mean Q or R. Okay? Let's construct a truth table for this. Okay, so we have P, Q, and R. And then the parentheses, so P and Q. And then the whole left statement here, we have P and Q or R. Okay, for the right side, the parentheses first, we have P or Q or R. And then the whole right side statement. Okay. Sketch. Okay, so since we have 3 variables, so now 2 cubed is 8, right? So we need 8 rows for this. So we have true, 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 false, 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 true, true, false, false, true, true, false, false, and then true, false. Okay, so we have P and Q. So P and Q, true and true is true. True and true is also true. True and false, false. False, 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 and false. Okay, so now we look at this column and R. Okay. So this row or this row, so true or true is true. False and true, false or true. Also true, true or false, true, false, false, false. True, false, true, and false. Okay. Our 6th column, we have Q or R. So now Q or R. So true or true is true. True or false, true, true, false, true, 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 false. Okay, so now P in this row. Okay, so true and true is true, 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 false, 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 and false. Okay, so let's name this one P5 and P7. Okay, let's look at the truth values of these 2 columns. Are they the same? First, we need to look at the true is true. This one, same. This one is the same, but there's appears a true and false. So it's about this. Okay? So we just need to determine if at least like one line is, they have like the different values, true values, and we can jump to the conclusion that they are not logically equivalent. So we can write our conclusion like this: since P5 and P7 have different truth values, therefore they are not logically equivalent. Okay, that is our example.